Hello everybody, and welcome back to Block 6, where I'm going to show you the basics of measuring an azimuth on your map, as well as how to shoot an azimuth with your compass in the field. These two skills, along with what you've already learned in the last 5 blocks, form the foundation for all map and compass land navigation. I'm very excited to get into it. But before we begin, you will need to have either a baseplate or a lensatic compass, a map plotting tool, a ruler or straight edge, a pen or pencil, as well as a small notepad. And in addition to those things, you're going to also need to download and print the Yosemite Falls and the Yosemite Valley map excerpts that I've attached as well in the description. I will leave links in the description to the items that I'm using in case you're interested in getting your hands on them. Also in the description are links to the USGS website where you can download the full digital versions of both the Yosemite Valley National Park map and the Yosemite Falls map if you want to. I'm going to show you 3 ways to measure direction on your map. For the first 2, we will use a compass, and for the third, we will use a map plotter. All 3 methods will give you accurate measurements, but the protractor method is best suited when your map is marked with grid lines across the body that you can use to line up on. At the end of this lesson, I will share with you the pros and cons of each of these methods so that you can better decide which is best suited for your situation. For maps with no lines, such as our Yosemite Valley map, a baseplate compass that's adjusted for declination makes the task really easy. Once you learn how to measure an azimuth on a clean map with a compass, you really don't need to learn the other methods at all, since the method for measuring azimuths on clean maps can be used on all maps, regardless of whether they have grid lines or not. I recommend, though, that you learn these 3 methods, since each one has its pros and cons, and it will broaden your skill set and give you other options to fall back on if needed. In navigation, direction is the line on which something is moving or pointing, and we express it as an angle measured clockwise from north with its apex at the center of a circle that's divided into equal parts, either degrees, mils, or gon. If you're not paying attention when measuring these angles, you can very easily make the mistake of measuring the exact opposite angle of what you want and getting what's known in navigation as a back azimuth, such as 0 and 180 or 45 and 225. This occurs because when we measure an azimuth on the map, we're measuring a straight line between 2 points. The conceptual angle that this line represents is invisible, which makes the direction of travel along the line extremely important to keep in mind. Take a look at this illustration. This single line can be expressed in 2 different ways depending on whether you're heading to the mountains, which is 330 degrees, or back to camp, which is 150 degrees. Now, let's reach back to our 5th grade geometry class when we learned to measure angles with a protractor. When using a protractor to measure an angle, we don't just lay it on the angle any which way and take a reading. We need to orient the protractor to something first. This is where the grid lines come in. But it's not enough just to line up our protractor on a grid line. We also need to make sure that the circle we are using to measure this azimuth is centered somewhere on the azimuth itself. Once this is all lined up, we can then take a reading from the protractor, making sure that we're not reading the back azimuth. A simple technique that helps to prevent calculating the back azimuth is to draw your azimuth line between the start and finish point, but extend it slightly beyond your finish point, and add a small arrow at the end to indicate your direction of travel. This provides a clear visual reference when aligning your plotter or compass, making it easier to see which side of the scale you should be reading from. Let's take out our Yosemite Valley map excerpt and find a good start and finish point that we can measure the azimuth between. Look at the bottom center of the Yosemite Valley excerpt and find Mount Star King. Follow the red dashed line northeast until you find Cloud's Rest. This is a nice straight line that we can measure without having to draw anything on our map. But having a straight line between 2 points isn't enough. We need to know the direction of travel, since, as we just saw, this line can be expressed by 2 different azimuths depending on which way we are traveling along it. Let's say we are standing on Mount Star King and we want to know the azimuth to Cloud's Rest. In this scenario, I would put a small arrow on this line somewhere around here to indicate my direction of travel. Okay, now that we know where we are and where we want to go, we can begin. In our last block of instruction, we set our compasses to the current true to magnetic, or TM declination angle in Yosemite National Park. I think that was 12 degrees east. We chose to use the TM angle instead of the GM angle since our map didn't have any grid lines to line up on, and we needed to use the longitudinal neat lines as a reference to orient our map. When we adjust a compass to the TM angle, we are in a sense turning our magnetic compass into a true north compass. Meaning, when the bezel ring is set with N towards the index line, and we put red in the shed, the compass and the direction of travel arrow are oriented to true north. The needle will always be oriented to magnetic north, but when we align the needle into the orienting arrow, the compass is automatically offset by the amount and direction of declination that we entered. This one-time adjustment to our compass is what allows you to take the true azimuths from your map and directly follow them with the compass without any further conversions. Of course, if you plan to use your compass in another area where the declination is different, you will have to readjust your compass accordingly. Because our compasses are already dialed in for the 12-degree east declination, we will begin this block of instruction by learning the method of measuring true azimuths on a map with no lines using a baseplate compass with adjustable declination. First, let's align our compass to a neat line and then turn the compass and map together until red's in the shed. Our map is now oriented to true north, and for this method, it is critical that the map stays oriented. Even the slightest turn of the map can affect the accuracy of all azimuths measured in this manner. If you're doing your map planning somewhere that you can tape the map down or use something heavy to hold the map in place, I encourage you to do that. Movement of the map after orienting is the #1 reason why students using this method wind up with a bad azimuth. After you have secured your map into position, you can then align your compass between any 2 points and measure the true azimuth between them. Let's do that now with our Mount Star King to Cloud's Rest line. When you turn your compass away from the neat line, you're going to notice that the magnetic needle is no longer in the orienting arrow, meaning red is no longer in the shed. That's okay. Once you align your compass to the Star King line, you will need to hold the body of your compass securely in place so that it remains aligned on your intended direction of travel, while you turn the bezel so that red is again in the shed. Now move your hands away and check that the compass is still aligned along the Star King line. The direction of travel arrow is facing the way you want to go, and that red is perfectly aligned inside the shed. And when those 3 things are good, you can read the azimuth at the bearing index line of your compass. Remember, since we aligned the map to true north, the azimuth you see is a true north azimuth. When I measure this azimuth, I get about 20 degrees. It's nearly impossible to pull an azimuth to the exact degree since the bezel is graduated in 2-degree increments. It's a bit like trying to measure millimeters with a ruler that's graduated only in centimeters. All right, no further calculations are necessary. You should write this azimuth somewhere so that you have it and don't need to remeasure it later. If you're calculating additional azimuths, for example, if you're planning a route with multiple legs, then you should go on and repeat this process for each leg on your route, especially if your map is secured well and you have a comfortable spot to work in. You may find yourself in this same situation with a clean map, but with a baseplate or a lensatic compass that doesn't have adjustable declination. The process is nearly identical with a few minor tweaks. With a baseplate compass that has no declination setting, or with a lensatic compass, you will need to know the magnetic declination for the area that your map covers. In the case of our Yosemite map, we know that the current declination is 12 degrees east. If you are using a baseplate compass, you need to first make sure that the N or 0 on your bezel ring is turned to the bearing index line. And then you can align your compass along a neat line and turn the map and compass together until the north or red end of the magnetic needle points to the N or 0 at the index line. If you're using a lensatic compass, you can simply align it on a neat line and turn the map and compass together until 0 or N is under your index line. But in this way, we have aligned a true north line of longitude to magnetic north, which isn't really what we want. True north actually lies to the left of magnetic north by 12 degrees, so we need to turn the map and compass to the left 12 degrees. Remember our rule. When we go from true to magnetic and the declination is east, we subtract. So a 0 degree true azimuth minus 12 degrees of easterly declination equals a 348 degree magnetic azimuth. If you're using a baseplate compass, then you can turn your bezel until 348 is at the index line, and then turn your map to the left until the red end of the magnetic needle is pointing again to the N or 0 on your bezel. If you're using a lensatic compass, just turn the map to the left until 348 is under your index line. For anyone who may be wondering why when we subtract 12 from 0, we get 348 and not negative 12, remember that 0 and 360 are synonymous with one another when referring to direction. So that means the first degree to the left of 0 is actually 359 degrees. Depending on who you're listening to, you could hear either 0 degrees or 360 degrees mentioned as a reference to north. Okay, once you have turned your map so that 348 degrees is at the index line, and you have checked that the compass is still aligned with the neat line, your map is oriented to true north. Pin the map down now, securely, somehow, so that it will not move accidentally. And you can begin measuring magnetic azimuths with your compass. Simply align your compass on your intended line of travel, then turn the bezel ring so that red is in the shed. You can now read your magnetic azimuth at the index line. This is a difference that you need to understand between this method and the first. In the first method, we adjusted the compass to correct automatically for declination, which allowed us to kind of forget about magnetic altogether. But in this method, we need to remember at the beginning to adjust for magnetic declination when we first align our map. Because the compass has no declination set into it, the numbers we read at the index line are magnetic azimuths. Once the map has been oriented, we can measure these magnetic azimuths with our compass and use them directly without having to convert. The third method, and my preferred way of pulling azimuths using a compass, is to use a map with grid lines on it. The Yosemite Falls map excerpt that I've attached has grid lines for us to use, so if you're interested in following along, you should print that and have it available. The grid lines introduce another option for us to use as a reference for north that remain constant over time, just like true north lines. Which means The relationship between them, or the grid to true angle, is also unchanging. On most maps that have grid lines, you'll find that the declination diagram will show the relationship between grid, true, and magnetic north. Our Yosemite Falls map is no different. As you see here, as of 1997, grid north lies 1.5 degrees west of true north. That has not changed, while magnetic north lies 15 degrees east. But that was in 1997, and as we know from our online research, the current magnetic declination is 12 degrees east. Let's use the most current information that we have. That means if we want the grid to magnetic, or GM angle, we need to add together the 1.5 degree difference between grid and true and the current 12 degrees of declination from true to magnetic. So 1.5 degrees plus 12 degrees equals 13.5 degrees. So we say that the GM angle is 13.5 degrees east, since magnetic north lies to the east of grid in this area. For our navigation purposes, you can choose to use either 13 degrees or 14 degrees. Okay, a quick fact to keep us from becoming too technical. If we could walk a perfectly straight azimuth through the wilderness for 1 kilometer, which I've never done, and we happen to walk exactly 1 degree off course the entire way, we would miss our intended target by about 17 meters. That's roughly the length of a volleyball court. I bring this up so that you understand that when the math says 13.5 and I say choose 13 or 14, it won't make much difference. First of all, a 17-meter deviation over 1 kilometer means even if you needed to walk for 3 kilometers, you would still be within about 50 meters of your intended target. And secondly, your intended target is probably not an ammo can stuck on a tree somewhere in the middle of the woods, like it was for me when I had to compete in my military navigation events. It's going to more than likely be a mountain, a hilltop, a tower, or some other large and easily recognizable terrain feature, which you will certainly see if you're within 50 meters of it. In our next block of instruction, I'm going to teach you how to plan a route. And in that block, you will learn some techniques that will help to funnel you into your target. In the meantime, though, we're not going to get bent out of shape over 0.5 degree. Even my military students were allowed a plus or minus 3 degree margin of error. For this example, I'm going to choose 13 as the GM angle, and now I'm going to set that into my compass. Okay, because we previously set the compass to 12 degrees east, I only need to push the declination another degree further. Each tick mark on my declination scale here denotes 2 degrees of change, and since I'm already at 12, I just need to push it halfway to the next tick mark to reach 13. Now that we have set our compass to grid north, that means we can use it on the map with the grid lines to measure grid north azimuths, and when we shoot azimuths in the field, we will be reading grid north azimuths directly from the bezel. Now that our compass is set to the GM angle, we can get to work. With this method, there's no need to orient the map to pull azimuths. You can work with the map turned however you like, and there's no need to secure the map in place. This makes the method much more user-friendly and reduces the chance of error related to map movement. If you choose to orient the map for situational awareness or terrain association, you need to remember to use any north-south running grid line and not the neat lines. First, make sure your bezel is turned so that N or 0 is at the bearing index line of your compass, and then simply align your compass on a grid line and turn the map and compass together until red's in the shed. Your map is now oriented to the landscape. Now let's imagine that we hiked up to the Indian Rock mountaintop, located in the 7584 grid box. Remember those grid boxes from block 2? First read to the right and then up. From here, Our next objective is the Snow Creek Ranger Station located in the 7785 grid box. If you look closely, you'll find a small dot at the top right of the letter N in the word cabin, which indicates its exact location. Let's use a straight edge to draw a line on our map from where we stand to the cabin, like this. Remember to draw the line long through your finish point and label it with an arrow indicating your intended direction of travel. Take your time to make sure the line travels through your exact location as well as the finish point. Now, align your compass to your intended route, making sure that it's pointing in the direction you intend to travel. We don't want to measure the back azimuth. There are two ways to do this. One may work better than the other in certain situations. I'll quickly show you both and you can decide which you prefer. The first way is, of course, to align either of the straight edges of the compass to your line, like this. The second way, and the way I prefer to do it, is to use the tip of the direction of travel arrow at the bottom of the base and the little notch at the top of the base just above the index line. I line my drawn azimuth up on these 2 points, and then my azimuth runs directly under the bezel. Both techniques are acceptable. When we use this method to pull azimuths, the magnetic needle and where it's pointing are of no concern. We are simply using the compass as a protractor. The next 2 steps are critical to understand and get right. First, your compass must be aligned with and pointing toward your direction of travel. That means the red direction of travel arrow or triangle here must absolutely be turned in the direction you intend to walk. And second, the N or 0 on your bezel ring must be facing towards grid north of your map. In order to get that alignment perfect, you will need to use the orienting lines to either line up on a north-south grid line or become parallel to a north-south grid line, as you see here. You can slide the compass along your azimuth if it helps you to align the orienting lines in the bezel with the grid lines on the map. It often happens that when you're trying to line up the bezel with the grid lines, the compass shifts a little bit too. That's why I always recommend to take a final look at both alignments before taking your reading at the index line. If you find that you needed to readjust the compass alignment, make sure to take a quick look at the orienting lines as well. So, after checking all my alignments, I get something between 76 and 77. And my teenage daughter is telling me I should go with 76. Who knows why? With very little practice, you can become extremely efficient at measuring accurate azimuths from your map using this method. Now I'm going to show you what I consider to be the best and my absolute favorite way to pull azimuths from a map with grid lines, and that's with a map plotter. Map plotters come in a variety of layouts. You can find them all over Amazon if you're interested. The one that I use is pictured here. I could spend a lot of time telling you why I love this piece of kit, but this is already going really long. If you don't already have one, buy one. You will take your map and compass skills up a notch by adding this into your kit. You can make this tool even more practical by simply adding a piece of paracord guts to it like this, as you see here. If you decide to do this, make sure to tie the knot on the top side of the plotter so that you can still lay it relatively flat on the map. Of course, the string isn't necessary. It just allows you to collect azimuths without having to draw lines. Let's go to the map now so I can demonstrate to you how this cool tool works. Okay, as you can see, On the outside, there are two sets of numbers. The inner set is degrees marked from 0 to 359, and the outermost are mils from 0 to 6,399. Unless you're working with an artillery unit, you will likely never need mils. You could theoretically cut them off entirely and reduce its size a bit, making it easier to pack into a small nav kit. Within the body of the plotter, there are three triangles. They are for plotting grid coordinates on different scale maps. I'll be delivering a course on that later. They are marked in meters for use with various scale maps, 1 to 25,000 up to 1 to 250,000. And I often use them to measure distance, especially on a 1 to 25,000 since the scale is graduated in 20-meter increments. The crosshairs in the middle are there to help you orient the plotter to the grid lines on the map. They serve the same function as the orienting lines in the bezel of your baseplate compass. Besides that, it is also a handy straight edge. So let's use it now to pull an azimuth. Take a look in the 7584 grid square and locate Indian Rock. I need to get back to the trail intersection at the bottom of the 7485 grid square. Let's draw the line and measure the grid azimuth to that location. Now that the line is drawn, I can easily see where it crosses a grid line. That's where I'm going to center my plotter, since it will be very easy to align it there. Okay, this was a pretty short route, and even though I drew my line a little bit long through the finish point, it still doesn't really reach the degree tick marks on my plotter. I could eyeball it, but I'm always trying to teach you how to minimize error, so I'm just going to extend my line a bit. Okay, after extending the line and realigning the plotter, I can see that the grid azimuth from Indian Rock to the trail intersection is 305 degrees. Now, since my base plate is already adjusted for grid azimuths, I just need to turn the bezel until 305 degrees is at the index line. Now I'm ready to put red in the shed and follow my compass to the point. For me, working like this with a plotter and compass together makes the map work enjoyable. And I actually find myself looking forward to each new leg of my route so that I can get my tools out and do it again. Now let's talk about shooting an azimuth in the field. First of all, if you're using a compass with declination preset, keep that in mind. I say to keep it in mind in the case that you're ever in a situation where you need to communicate an azimuth to someone else. In this case, you should either convert it back to magnetic or make sure that the person you are communicating it to is aware that it is either a grid or a true azimuth with whatever amount of declination you have entered into your compass. Okay, this isn't really a class about rescue measures, so let's move on. The absolute best compass, in my opinion, for shooting azimuths in the field is the Model 3H lensatic compass by Kamenga. I will do a short video on this compass another time. Let's just say now that as far as shooting azimuths go, the ease of use and ability to get fast, accurate readings with this compass isn't comparable in any way with base plates. As I mentioned in a previous block, base plates excel in the map work department, but trying to shoot accurate azimuths with them can be a little finicky. In Sunto's manual, they describe a kind of compass-to-cheek holding method of shooting an azimuth with the MC2G, suggesting that the user should fold the mirror back and while holding the compass to their eye, sight a target through this little sighting notch and then line up the bezel so that red is in the shed by aligning the red side of the magnetic needle to the orienting arrow. If you're lucky and the target and you happen to lie on or close to a north-south orientation, then being able to see that red is in the shed from the reflection might be possible. If you have to put red in the shed from an oblique perspective, meaning you're shooting across the north-south line, then expecting to get an accurate azimuth using this method is unrealistic. What I recommend you do to give you the best chance to get an accurate azimuth is to use the compass holding technique I taught you earlier, where the compass rests flat in your hand and is pointing directly out in front of you. Turn your body and compass as a single unit until you're facing your intended target. Then simply tip your head up and down to check your alignment, and then put red in the shed by turning the bezel ring. Once you've done that, you can read the azimuth on the bezel ring at the index line. In this way, you have an over-the-top perspective, and this parallax effect you get from viewing the bezel from such a close and oblique position is eliminated. Use the mirror to shave, check your teeth, and reapply your lipstick. If you need to signal for help, it's also practical for that. Now practice these methods. You'll probably find that one of them suits you the best. But don't forget about the others. Learning and practicing these different methods keeps you flexible and proficient. It's this kind of training that will help you to build the skills you need to give you the confidence when it matters. Okay, as promised, in the last few seconds of this block, I will put up a slide with the pros and cons of each of these methods. You can pause the video and spend as much time there as you need. You won't want to miss out now on the nav tips and techniques that I'm going to share with you in the route planning block. Let's now put red in the shed and continue on our azimuth to block 7, the last block in the basic land navigation course. I'll see you there.